Thank you, Martin, for such a generous presentation. So I'm Uri Yerushalmi. I'm the Chief AI Officer and co-founder at Fetcherr. I've been building various types of decision-making products, always around AI, machine learning, and data science for more than 3 decades now. My academic background is including a PhD in computational neuroscience. And for the decade before founding Fetcherr, I was head of AI in an algorithmic trading firm, Wall Street based. And therefore, most of the principles that I'll be presenting today are inspired by decision-making processes in algorithmic trading and high-frequency trading. So when we look at the landscape of generative AI models, we can classify these models to various groups. The most dominant group today is the group of large language models that you all know. These are models based on principles of deep learning, where the input is textual-based, textual tokens. These models are learning textual data and outputting textual data. We also know visual models that are trained on images or video. And in the recent years, we have seen also the emergence of large world models that are simulating our physical environment for the sake of robotics. Now, based on our experience in decision-making, mainly in algorithmic trading, we have understood that in order to make decisions relating to market environments, it's not enough to use such models. We need some model that would understand market dynamics and be trained on market data. Therefore, during the recent 6 years, while most of the AI community was focused on large language models or visual models, we were focused building large market models, which are based on same types of principles of deep learning, different types of layers of deep learning, but this time with a twist where they are trained on market data and outputting the anticipated market dynamics. Now, I've compared these large market models to video models, for example. Video models are models that you all know, where they are trained on visual data. Let's illustrate what do we mean by large market model by comparing them to large visual models. These visual models are presenting things like what you're looking at, which is not real, no camera filmed it, no drone flew over it. It was generated by a Gen AI model, not by tracking every drop here or every leaf, but by understanding how things behave. It's not just a playback of historical data, it's a system that truly understands the probabilistic distribution of what's likely to happen next. Now, what you're looking at is Gen AI applied on nature. It can also be applied on markets. Like nature, markets are live, complex, interconnected, and always moving, and they have some players inside them. And these players, they don't see the full picture. They're acting on lagging signals, usually acting too late. But now, with the presence of these models, some of the players can have access to the underlying structure of the market. And these players can move differently. They don't need to follow the market. These players can move before the market moves. And that gives them very significant advantage in competitive behavior, in competitive landscape, as we will see in a moment. Now, you may wonder about the output of such large market models. We know the visual models, like the video that I've presented before. The video models are outputting 4-dimensional data, In video, we have the height of the video, the width of the video, the time dimension of the video, and the color dimension. So overall, we're talking here about 4-dimensional data. In market models, the modality is very different. We're talking about a lot of more dimensions. It's a hyper-dimensional output where we have several dimensions relating to time. For example, the time of certain transaction. We have the time of the execution of the transaction. That might be different. We have we have dimensions relating to the features of the product, several encoding of the product, or some dimensions relating to the provider of the product, or to the buyer of the product. So we're talking here about many dimensions. And in every combination of such dimensions, just as in the video case, we have pixels. But these are not visual pixels, but pixels relating to certain probabilities, like the probability of demand being in a certain value, or the demand elasticity, or cross-elasticity, or some competitor price positioning, and so on. So overall, we covered how does the output of the large market model looks like, but why do we need these large market models? The issue is that we've seen generative AI models in the market for a while now, for several years, but we have not seen yet that tremendous impact on businesses as we would have expected. We are seeing magnificent tools out there. Some of these tools are presented here that are going to reshape industries, but we have not seen yet any business that has shown significant growth thanks to these technologies, or any business getting close to being much more autonomous because of these technologies. So there is a missing link between the two, and we in Fetcherr, we believe that we are presenting that missing link to gap between these two chains. Now, we believe that the missing link is there because of some limitations of the existing models. For example, large language models, because they are trained on textual data, large language models are qualitative by nature. But in order to take business decisions, qualitative is not enough. We need some quantitative information, some quantitative predictions, because business decisions by nature are quantitative. And we also need to make autonomous decision-making, we need the thinking to be much more business-oriented, while the large language models are more converging into being oriented toward replacing humans, imitating humans, empowering humans, and reducing the human resources cost, while the goal of the business is just to drive more revenue and be much more optimized in its operations. And therefore, when we are presenting the large market models are different in the sense that they are trained on market data, they are quantitative by nature, their way of thinking is multidimensional because they can go beyond the human reasoning because they are not trained only on textual data, but on business information. Therefore, they are designed in their essence to drive revenue and to optimize operations. And we have been in the market for several years now, and every time we are presenting this decision-making process in an enterprise, in a business, we see a shift or a change in the market dynamics. What you're looking at here are several products and the price in which the product was available before the Fetcherr system is out and after the system is out. And we can see that in the manual case or in the rule-based systems case on the left, the prices change quite rarely. They change very correlatively. But when AI systems come into play and make the right decisions, every time a hint flows from the market, there is an immediate reaction in the market, and the changes are much more gradual and much more pronounced over time. It is also very proactive, not only reactive, because it knows how to anticipate the future market dynamics. Now, the large market model is not the only component in the system. There are many components in such a system because the system eventually needs to make a certain decision. The large market model, by its nature, is passive. It only makes predictions. So let's take a look at the pipeline of decision-making in such a system. Initially, we need to consolidate data from various sources. That data is used to train our large market model. And the large market model is capable, once trained, to predict future market dynamics. And based on these dynamics, it is possible for us to make computationally intensive simulations about what would be the results of various decision-making policies. We choose the decision-making policy every time that is expected to generate maximal reward for the business and inject it into the right places. When looking at the data is split into the internal data of the business, and in addition to that, we have the external data that we add on top of that. The internal data of the business includes the businesses, the transactions, orders, prices, and so on. And on top of that, we add external information that might be relevant for the decision-making, like information about capital markets, about competitors' behavior, and so on. All of that data is consolidated into one place and is used to feed the large market model. Now let's take a look at the output of the large market model, because as I said before, the output of the large market model is multidimensional, and we as humans we are not that good in looking at multidimensional data, so we data scientists like to reduce the dimensionality of what we are looking at to 2 or 3 dimensions. And what we have done here, for the sake of the presentation, we have reduced the dimensionality by slicing that multidimensional cube at a certain point, meaning we are looking at a very specific case here of a very specific product that might be sold at a very specific time to a very specific customer, but by a specific provider. So the only parameters that we are allowing ourselves to play with are the price of the product offered by the customer, by our customer to its customer, and a price of some competing product on the y-axis. On the x-axis, we have our own product price. On the y-axis, the competing product price. And the colors here are representing the expected demand. This output is generated by the large market model. It's not generated by a pricing analyst. And you might note that the colors make sense because the blue areas are areas of low demand. And this low demand is expected where our price is higher compared to the competitor price, and the red areas are in the opposite case. There is also an equilibrium line between the two that might also be very interesting, where our price is comparable to the competitor price. Now, it's very interesting to look at these slices because comparing different markets gives us some insight into how does the large market model see things. For example, how does it compare two markets where here in this case, the right market has low impact of the competitor compared to the left market. Or slicing that cube in different places shows that in this case, the large market model thinks that the right market, in the right market, the perceived value of the product is higher than the competitor compared to the left market. That's done by the shifting of the equilibrium line, or markets where by nature they are much more competitive, where every cent matters, every pixel matters in these cases. So these outputs are generated by the large market model. And once the large market model is capable of outputting these interesting multidimensional cubes, we have a simulation engine that scans the possible decision-making policies. So every decision-making policy is simulated intensively, checking every day, every hour, how does a certain decision-making, how does it influence the demand, how does it influence the competitor, how does the competitor is going to react, how is my inventory going to be influenced by my decision-making, until the end game is computed and we compute some rewards, whether it's revenue or market share and so. And we are simulating all of the possible decision-making policies, scanning that landscape of decision-making policies, and for every decision-making policy, we have a certain reward outputted. And among these rewards, we have a process of choosing the decision-making policy that is expected to generate the maximal reward for the business, whether it's market share or revenue or profitability, whatever the business chooses. And the interesting thing here is that once we apply this on businesses, we see repeatedly that the outcomes have a very significant statistical significance. So when we are doing some A/B testing, comparing a control group of markets where the decision-making system based on AI is not applied, and comparing that to markets where it is applied, we're seeing these gaps that you might see here. Some of the gaps are gaps where the blue lines, blue in that case is the target group where the decision-making process is applied, and the orange ones are the blue ones are the target group, the orange ones are the control group, and the gaps are showing one significant thing, that the decision-making is very profitable. And over years, in every different scenario, we are seeing in every different customer repeatedly that there is a revenue uplift of more than 10%. And the byproducts are the reductions in human resources and so on, and relating to the accuracy of things. Now, we have seen in this competitive environment that having access to that decision-making process based on AI gives a lot of advantage to certain competitors. And in these competitive landscapes, we have the competitors that act, and we have the players that are acted upon. But whoever has this access to the underlying structure of the market can shape the right outcomes and win. And winning or survival in that case is no longer dependent on the traditional attributes of being bigger, being faster, having smarter employees, or having better intellectual property. It's based on having the right access to the AI decision-making tools. Thank you.